So I'm going to record the lecture today. So the lecture we have Monday is not recorded. Okay, so let's go chapter. Okay, last time we talked about the historical simulation and extreme value theory. So we continue that topic. Okay, the first we wanted to see is that if you see the historical simulation, how you're gonna do that? Okay, so basically you choose the value of the day n. Okay, the day n, which is you have a series of data, which is the last one. That's the day n. So total number of observation. If you have n days, that means the last one in your data set. Okay, this one is your last one in your data set. The other is you see the VI and divided by VI minus 1, that's the daily return. So it's going to be the return of the daily return. So that's how you do historical simulation. And so we have a data set. Yeah, we click on the sample we have here. Okay, the first we have the data. So remember, so we have 4 different. This is index. Okay, 4 different index. Okay, this is from the U.S. Dow Jones Industry Average Index, and you have the FTSE from London, and you have CAC 40 from Paris and France, and also you have Nike, okay, from Japan. So those index different currency. So for those 3, from London, France, and Nike use different currencies. So that's why we use the exchange rate and to get all of them dollar value. Okay, next we create different scenarios. So how you create this scenario? Okay, this is how you do that, okay? And when you create a scenario, it's going to do is, okay, this number is the first one is a 10977. Okay, remember this is the first one you got. Okay, is from this PowerPoint. Have this PowerPoint. Like, see, we have the last one, the VN, which is we have the total number of the observation is n. Okay, total, that's the last one. So we have, for example, we have this data set. Okay, how many data we've set we have? Okay, we have 504 and 504. Okay, that's the total number of observation. Okay, that's the last one. Okay, last one. And then you have the variance. You want to calculate this, which is the return. Okay, is the ice trail assumes that the value of the market variable and then tomorrow. So we create a series of a simulated simulate value, do simulation. Okay, so this is how you do this. And the simulation is going to be this one divided by previous one, right? And then you times the last one, which is this is the last one. Make sure that this is the last one. You need to fix that, okay, because you don't want that number to change for the last one. Okay, that's a 10977. So you drag all the way down. You can see 10925, 11070. So you generate a simulation data. Okay, simulation data you paste in another Excel spreadsheet. Okay, paste in another Excel spreadsheet. Okay, that's the new data you get for Dow Jones and FTSE. Do the FTSE and everything the same thing. Okay, all of them are the same. So you can do this while it's the same. Let's see. And then you times H504 all the way down. Okay, and then you fix that. You press F4 and then you add a dollar sign. Okay, that's for you drag all the way down. You have the FTSE. So right, 95699676. So it's actually how we got the data. Okay, the new data we talk about is a simulate. Okay, this is all the data is historical simulation. Okay, you simulate. It's not the real. Okay, the real data is from the one you retrieved from the Yahoo Finance or somewhere else. That's the real data. Okay, the other is a simulate. Okay, so once you have that, and then what you need to do is you calculate the portfolio value. Okay, the portfolio value. So what is the portfolio value? Because the portfolio, you see, you invest 400 in Dow Jones, 4,000. Okay, actually this is there's a 4 million. So you have another, say, in thousands. So that's the unit. 4 million and 3 million, 1 million and 2 million. So you have invest in these 4 different index. So what will be the value of your portfolio? What will be the value of the portfolio? So how you calculate the portfolio value? So the portfolio value is going to be your investment. Okay, this is L2, that's your total investment. Time, okay, times the B2. Okay, the B2, right? The B2 divided by the D504. So that's the last one. You have the from the previous day. So we have the D504. Remember, we got from this data set for the last data. So that's how you get the portfolio. So when you have the portfolio value and use that, okay, this is the value, and use the total, you sum them up. This is Okay, that's your total investment. Okay, actually, this is your investment. It's 10 million US dollars. So you use 10 million or 10,000 minus the portfolio value. So that's your losses. So you have all the losses right here. So that's what do we do? Okay, so we get all the losses. Okay, so you have all the losses. So remember, so we have all the losses, and this is the corresponding scenario. So we get these two columns copied. Okay, so you copy this two, and then you have the scenarios. Make a copy, and then you, let's say you insert another graph, another Excel spreadsheet, and then you paste, only paste the values. Do not paste the formula. So you have to paste the value, right? Let's paste the values. Okay, there's a different scenarios. Now what we do is that you select the whole Excel spreadsheet and using data. Okay, you sort the data. Okay, sort by the losses. Okay, the sort by losses, you have the cell value from the biggest to the smallest. Okay, that's how you get the losses. Okay, this is a scenario of 494, and that's the 477 and 1,000. That's the maximum loss. Okay, so that's exactly how we got the data in that ranked losses. We're using equal weight. So equally weight, ranked losses. So how are you gonna calculate the VaR? Okay, so the question is that they ask you one day, 99% VaR. So the first we wanted to know how many total number of observations we have. So we count a total number of observation. Okay, we count. So we count all those values. Okay, total number of observation. Okay, all the way down, still here. So we have here. Okay, so we have okay, a total of 500 observation. What about 99%? What is the one day 99% VaR? Okay, so 99% VaR, that means 1% loss. Okay, what's the maximum 1% loss? So you will see the loss of the observation is going to be 1. Okay, this is the total number of observation times 1 minus that 1 minus that 99%.
Yes.
Okay, 1 minus 99%. So you have you will see that is the 5. Okay, 5 is the that's gonna be the VaR. Okay, the VaR of that 99% VaR or 1% VaR. Okay. So how you get that is it's going to be ranked the fifth, okay, the fifth largest loss. Okay, 1, 2, 3, 4, 5. Okay, that's the fifth largest number is that 253 and 385. Okay, so that's the 99% VaR based on historical simulation. And what about your expected shortfall? So how you calculate expected shortfall? So expected shortfall will be the average of the, okay, the most, okay, biggest losses, okay, until that 1% more. So that's you take the average of the past 5 most biggest losses. So that's gonna be, this is the expected shortfall. So your expected shortfall will be 327,000. Okay, one of the question is you wanted to know the VaR, right? So you can do is there is called the small. Okay, the small. So you can select the whole array. If you didn't do the rank, you don't want to rank all those data, and so it's okay. Okay, you select all those data, and then you choose the fifth smallest one. You choose number 5. It will give you the VaR. Okay, that's the VaR of this. Okay, let me see. B2, B501. Yeah. So we have the 290. Oh, okay. So okay, so that's because the smallest one. Okay, because we using absolute value, okay, absolute values because of that. So we're using largest. So we choose a large, that's gonna be the value. Okay, so yeah, so we choose a large, it'll give you this exactly 253. Okay, that's if you don't wanted to rank all your data, okay, if you don't run all the data, so it's coming out with randomly, and then you can do is using Excel using large function or small function, okay. And one of the question with this, what's the problem with this, is equally weighted. So it's equally weighted. So you can see if you go back to check that, it will rank different, okay, from the scenarios 1, 2, scenario 1 and 2. So the losses will be randomly follow that, the sequence, okay, follow that sequence. So what we need to do is we wanted to give them a weight. So the weight is going to be some of the losses will be given heavy weight. So most recent losses will give heavy weight. So that's we call this one is exponential weighted moving average. Exponential weighted moving average. Okay, exponential weighted moving average. So you remember, so in last chapter we talked about we have parameter which is called lambda, and the lambda is the weight to give to most recent loss, and then 1 minus lambda that give the losses of previous period. Why you do that? Okay, so this is the theory we talk about, and is Baldock and Richardson and Whitelaw 1998 suggest that the more recent observations should be given more weight because they are more reflective of current volatility, okay, and the current macroeconomic condition. So that means most recent happened things will more related to the volatility or the changes in today. Think about that. That makes sense because the information is starting to have less and less impact on the market. So the people are starting to forget what happens, in the past. But the things that happened yesterday, they have more impact on the market. So so how we do, okay? So this is what we do, okay? So based on Bodek's in 1998 suggestion, so the worksheet we're gonna choose n is the number of scenarios. So we have the total number of scenarios y, and the n is 500. And we have the lambda, okay, lambda approach to 1, so which is we choose 0.095, okay, 99.5%. And this approach is the basic historical simulation approach, where all observations are given a weight of the n, okay, the inverse of the total number of observation. So we apply this one. This is the formula we're gonna do, okay? So for the weight, and so how we gonna do that? Okay, this is I create the losses and sort it by the different scenarios. That's okay, the scenarios from 1 to 3. Okay, we didn't sort that. Okay, the weight is going to be, okay, so lambda, okay, this is lambda, okay, remember that's the formula, lambda raised to the power of total number of observation, okay, so remember we have lambda equal to 0.5. We have n equal to 500. So the total number of observation is 500. So this, the lambda raised to the power of n minus 1, okay, n minus 1, n minus I, okay, it's not 1, n minus I. So I is a1, so the first one you have only the first observation. Okay, use that formula, and then you times 1 minus the lambda, okay, lambda f2. And make sure you so you fix that number, okay? And divided by 1 minus lambda raised to the power of n. Okay, raised to the power of n. Okay, that's your weight. Okay, the weight you have is right here. Okay, so how you get the weight? Okay, the weight is equal to lambda. This is lambda. Okay, remember the lambda, you have to fix it. Press F4 and you make that lot raised to the power of, okay, total 500. So you have 500 minus the number of observation. Okay, the first one minus 1 I raised to, and then you times, okay, you times 1 minus lambda. Okay, make sure you fix the lambda and divided by, okay, the whole thing, and then you need to, okay, this one. And divided by 1 minus lambda. Okay, so with lambda, we have F2. Okay, we do 1 minus lambda. Okay, fix that and raise to the power of n. So the total number of observation is 500. Okay, so that's the formula. So you can get that. So basically, that's how you calculate the weight. You drag all the way down, exactly the same all the way, right? So you have the weight and the losses, okay? And so, and next is going to do is that you calculate cumulative A cumulative weight. The cumulative weight is going to be the first one is exactly the same, the first, and the second one is going to be this one times a plus the weight, right? So it's going to be D2. This is you just calculate D2 plus D3, C3. So this accumulate, okay, cumulative. This one plus C3, and that's going to your cumulative weight. And this one is 0.0771 plus 0.02554. That's going to be your cumulative weight. So you, the first thing you wanted to do is that, okay, sort all the scenarios. Okay, use sort from the biggest to the smallest. Okay, sort them and to see their weight, corresponding weight. So we have the weight for that particular cases. So your cumulative, and then all the way down, you drag all the way down until 500. Okay, so now what we do is that the spreadsheet, so what is the weight, the cumulative weight is just greater than 0.01. So you set this probability. What is the probability about 99%? So 99% VaR. So 99% VaR, that means you will have 1 minus that 99%. Right? 1 minus 99%. So it's 1%. So 1%, the probability you're gonna lose is 0.01. So until what moment you can see, okay, this is the cumulative biggest loss is until the third one you will see you have 0.01, which is greater than 1%. So that's you choose this one. Okay, so this is the, okay, we have the D4, right? So what will be your VaR? Okay, so the VaR is going to be your B4, okay, B4, which is at this level. Okay, this B4. B4 is 282, right? 282. And the weighted average losses. So the weighted average losses, so you can see you have this one until this line. It's going to be the average of this. Okay. It's not going to be the average weighted. So we do is that you can see the weight for this one is going to be B2 times C2. B2 times C2, that's the weight. And this is a, okay, B3 times C3. So B3 times C3, okay, that's the weight for that. And then you have, the last is 282, right? And what is the weight? So the weight is going to be, okay, the 1%. So basically the 1% minus the accumulated, which is D3. Okay, D3, what is D3? D3 is C1 and C2, right? 1 and C2. So you plug them together, so that's gonna be the weight for the third case. So that's and so you put them together and they divide it by the total weight, which is I1. I1 is right here, so that's your total weight. So what will the expected loss? Okay, so I will do that again, so you know what I'm talking about. Let's see, we have the review data. Okay, okay. Now we have that to 0.01%. Okay, expected loss. So expected loss is equal to, okay, okay, this is the weight and the loss. Okay, the loss times the weight plus the loss times the weight, right? And plus the loss, okay, times, okay, what is the weight? Okay, the weight is going to be the probability, so we have to fix that, minus, okay, minus, okay, this is the weight, C2, and then you minus that, okay, say 3, so you have all this together, right? So together, okay, the whole thing, okay, because this is the sum product thing, you have the weighted losses divided by your probability. Okay, divided by your probability. So your expected losses is going to be 491 cents. Okay, so I have this one finished, so you can work on your assignment 4B. So assignment 4B, you can see the third question is asking you using exponential weighted moving average to calculate the VaR and expect shortfall. Okay. I think that's all. And so we are going to talk about, so you read the textbook and to talk about and to see and how that, you know, results coming out. Okay, it's really helpful. What I wanted to mention is two things we have in our course is that, and we have two different things talking about in the course. And one is about the survey. Okay, some of the students ask me question about the survey. Should I choose pass or fail, or should I choose regular? Okay, so there is something is gonna affect your GPA or financial aid or your transfer to a different school. Okay, so make sure there is some potential effect on this area. So to judge that pass or fail, okay, you need to make your own decision. Okay, for example, if you choose pass, your letter is P. Okay, but some of the university they won't accept your letter P when you transfer to a different school, and later on you have to retake that course, or you get a letter P and then some of the courses require at least a letter C as a prerequisite. So, but you have a letter P for your course, because some course may not allow you to use that course as a prerequisite. So that's some potential effect. And so it's something you need to make your own decision, okay? And another one question is about for graduating senior. Okay, if you are graduate in May, I have that in Blackboard. So make sure so you take that survey to complete your final exam by May 3rd. Okay, that's the last day. I have to report your grade by May 4th at 1 o'clock. Right, that's the second thing. The third one is going to be your course evaluation. So in history, so the student didn't do course evaluation, the response rate is low. So I wanted to really spend about 5 or 10 minutes and to work on that course evaluation and to get our good response rate. Okay, And feel free to let me know if you have any questions. And okay, don't forget to type your name in the chat box and to record your attendance. Okay, that's all for today, and see you next Monday.